Still seats in the front.
Not many though. Yeah.
This one.
Anyway, that's good.
There's a seat for a note taker.
Okay, alors, bonjour et bienvenue à Montréal. Good morning, welcome. This is Icnrg. We have an excellent front row seat for a note taker volunteer. Ah, there comes Mr. Moscow.
Mark, there is a seat beside the.
So while people are coming in, let's just get going. Quick reminder of the IETF IPR policy. If you contribute anything or you see anything that you know is associated to IPR, you are expected to let us know soon. Icnrg has the usual infrastructure. We have a mailing list and a wiki. We now use the wiki to publish info on upcoming meetings and so on. These are my co-chairs, Dave Oren and Börje Ullmann. I'm Dirk Kutscher. And yeah, as we mentioned, we really need a note taker to start this meeting. And note taking is really a light job. I mean, we don't capture all the presentations, just the question and answers. So the gist of the discussion. And there are no big formal requirements, so any text notes would be fine. Thanks a lot, Yannis. That's great. Okay, we have a cool agenda today. We give a few updates about what happened in Icnrg and ICN in general in a moment. We're not talking about the ICN when program. Sorry, I forgot to update the agenda. So Dirk is going to give us an update of the ICN over 5G draft and the ICN 5G LAN draft. Hitoshi is going to give us an update about the CCN info work. We have our ICN LoPan usage group item that has evolved very nicely. So Thomas is actually giving an update on this, and we think it's pretty ready. So let's look at that later. And Junga is going to talk about the two NIS documents, and we also assess the status of those. Is there anything we missed or that people want to add?
I have one thing that I need the HDMI.
Oh yeah, that's very important. Actually, it fits better in a later point in the agenda, but okay, never mind.
Oh, really?
Yeah, but
oh well, do it now.
Yeah, it's fine. So we had several side meetings this week, and this is one of those. Okay, there's a story to this photo. As you may have seen, the RSC editor has recently published the two CCNX drafts, so CCNX semantics and message formats. So thanks to the great work of the authors, Mark Moscow, Nacho Solos, and Chris Wood, this is now officially published. So thank you guys.
So we have experimental RFCs on the protocols after 6 years.
That's about right. So that's going to be more challenging now.
And the BIS work starts now.
Right, this is not the end, it's a new beginning. Okay, yeah, so then let's get to the say updates and information on what has been going on in ICN. So we had this interim meeting on Sunday. If you couldn't make it, so these were the topics that we discussed. Christian gave us an update about his ideas on say, yeah, push-based operation, or say push-based application semantics, and how that could be or should be mapped to say ICN network layers. And so there are different views how this could be done, and so also what the effect of push application semantics really have to be for the ICN network. Check out the presentation. So they are all in the data tracker already. So Mark had updated a draft on selectors in CCNX that can be used for discovery, for example. So that's the idea that you can basically attach predicates to the name in an interest packet, and then nodes that support this feature can basically give you information based on these predicates. We had a new version of the IPOC, so IP over CCN, draft by Greg. So we want to adopt this as a research group item. So that just for your information. We will also do the usual confirmation on the mailing list, but just to let you know that that was the outcome of the Sunday meeting. Ruidong talked about hop-by-hop authentication for CCNX and MDN networks. And then we had a presentation and discussion on ICN and QoS. So if you had been at the previous IETF meeting at the Icnrg meeting there, so there we had a longer discussion about ICN and QoS, and so basically explored the potential. So in general, the idea is that since when ICN, first of all, you have more resources that you can control that allow you to do something useful for QoS behavior. But also you have potentially more expressiveness in the, say, protocols, so in the names, for example, to actually classify flows, for example. And so this combination is a very powerful basis to do QoS, say, much better than we are able to do in IP. And so Thomas and colleagues had done some experimental work along those lines for IoT. In a very constrained network, of course, it's interesting and potentially quite important to manage resources, according to the application requirements. And so that presentation had some interesting results. So basically showed the great potential. And that was an interesting discussion. And so we have other documents on ICN QoS that, for example, talk about how to label flows, how to implement QoS treatment. So this discussion will continue hopefully next time at the next meeting. Okay, quick announcement. There's going to be the ACM ICN conference in September in Hong Kong, hosted by Hong Kong City University. The TPC meeting for the main program has just happened on the weekend, so the program will be announced, say, in a few weeks. So give us some time. But there is still an open call for posters and demos. So if you want to be part of that, please check it out and see how you want to contribute. So that's September 24th to 26th. So on the day before, September 23rd, there's a really cool event also in Hong Kong. So it's like co-located to the conference on using ICN, in this case NDN, for producing media. So that's Jeff Burke's activity. So trying to connect the ICN NDN community with the media and performing arts community. So should be really nice if you come to Hong Kong anyway. Consider attending the event as well. It's for free. And then the planning for ICN 2020 has started. So they are hosting opportunities. Börje sent out a call for hosting proposals recently on the mail list. So if you're interested to host a conference next year, please respond to that. Okay. Quick reminder, this is a almost but not 100% complete overview of, say, the work that we do in Icnrg. And so you see like the fundamental activities, so underlays, embeddings, core protocols, and then we have things like QoS that I just mentioned. I just brought up that picture again because of the photo that Dave showed earlier, because these are the core specs that we just published. And just to explain this, so this is a research group, so it's not that basically we produce like the one ICN standard. We don't do standards anyway. These are just experimental specifications. But this is just one way of doing ICM. That's CCNX. So this group is totally open to other ways, other protocols, other certifications. The whole idea is to document those that people are interested to use, that are kind of mature in some way, with the goal to enable more experiments and more cool research. So just to explain this is not basically the only technology or the only protocol that Icnrg is doing. And so this brings up the number of Icnrg RFCs to 6. So that's actually quite nice. And so we hope to get out more, say, useful specification documents like this. These are the say active research group drafts. So we will hear presentations on a few of those later today. Let me just quickly check. The deployment guidelines document, that's finished, or we think it's finished in Icnrg. What's the current status in the IRSG?
Waiting for IRSG final poll.
Okay.
And there's another one, which is the next one, the
disaster,
which is in IRSG final poll, and I think some of the IRSG members have yet to send in their poll votes.
Okay.
To the column. So both of those are within days to week or two from going to the RFC editor for final publication.
Right. There's one mistake here. This is the METME one. This is actually not a research group draft. I think it's just has been misnamed. We need to work on that to get that corrected, perhaps, or find a solution. And terminology is the same, so that's also, we believe, ready. And
well, terminology, there's just two-step process when we finish. We finish an RG poll, everybody's happy. The next step is there's an actual formal review by IRSG members. And I believe we are waiting to start that review, or is it in review? No, I think we're waiting. Is Colin in the room? No, all right. Well, we need to go bug Colin because he has at least 3 action items.
Yeah. But we will do that this week. And so there's one draft that is currently expired, but this is Flick. So file like ICN collections manifests for CCNX, at least so far. So that's also really useful and important, you could say, base technology that for CCNX. So we hope to resurrect this pretty soon. So Dave can say a few words.
So Christian and Mark and I got together earlier. I forget what day it was already. And we have a plan put together for finishing that draft. There doesn't need to be very much work on it. It's very solid. But there are 3 things that really needed to be done, which we will do in the next iteration, and we'll get it resubmitted. Number 1 is to formally define the extensibility model and how you extend the manifest formats, because that was underspecified. The second is to produce not just a CCN messages protocol mapping of manifests, but an NDN protocol mapping of manifests. So we'll have identical manifest formats for both underlying protocol architectures. And the third is that the way it works now is the pointers in the manifest are to raw hashes, which says that if the consumer wants to know something about the content, they actually have to fetch the content. So there was no capability of any type of annotations or small metadata that would give a consumer advice about whether they actually want to bother fetching that content or not. So we're adding annotations on the hash values. So an example of what you might use this for is if it's a manifest for a video asset, and each hash value is a frame of the video, you can annotate that with, for example, what the preferred fetch order is. Should you fetch in decode order or presentation order, and potentially other annotations. So those are the 3 changes, enhancements we expect to make to it, and hopefully have a new version for people to see in the near future.
Thank you, Dave. Just quickly again on the CCNX specifications. So if you're new to this group and you want to understand what this is about, of course, first of all, check out the RSCs. But other than that, Mark is going to give a short summary of those documents later today in IETF Open. So be there if you're interested. Okay, and so with that, this concludes our updates overview material. Dirk would be next.
Dave.
No, Dave is not next. So that was
You didn't take that
yeah,
out?
that's my mistake. So we do
Once
this.
again, I failed to deliver on the commitment.
We do this next time. It's my mistake again.
Okay, thanks. This is an update on the 5G, ICN and 5G draft. Ravi definitely wanted to be online, but I hadn't seen him actually on the online over there, and with my co-authors here. The updates relate to drafts that we've currently have as an IETF draft, which is the 4G draft, which I thought was in last call, but I might get that wrong. We also, and I'll come to this later, it relates to the next presentation draft, where we've taken things out and put it into a separate draft. This draft, as I said, is about enabling ICN and 5G systems, so it makes direct references to ongoing 5G work in 3GPP, and it leverages some of the design principles that are also included in the 4G draft. So it's good to also look at that draft, maybe in conjunction, if you will. And there's an overlap in authors, as you will notice. The updates in V4, we did a couple of editorial changes, so we combined the architectural pieces together to not have too many sections. We combined the actual next-gen core architecture, which talks mainly about the 5G components as they defined at 3GPP, and the specific part on how to actually extend the 5G core architecture with ICN support. That's being combined in a single section for editorial reasons. We also simplified the section that was new in VO3, which talks about the 5G LAN support, which is another area in the 3GPP work on 5G at the moment. And specifically removed the part that was a use case for this, the IP over ICN over 5G LAN to separate internet draft, which comes next. And that made the whole section simpler, and we only kept the actual ICN over 5G LAN piece in the actual draft. So it shrunk the section down. We also added a new description in a separate section called deployment consideration. So what we've done, we positioned the draft against the deployment consideration draft itself. So how does it fit in the categorization of underlay versus overlay, as well as the different migrations? And it's based on the latest version that's currently in the poll that the chairs outlined. So these are the updates we made. These are some of the pictures you can see in the draft, as well as the 5G core design guidelines that are being utilized. They are all being taken essentially from the various 3GPP documents that you can find in the references. The one that we added is the distributed LAN support that was added in version 3. Which is a new part that's being that's coming in. The work started initially for release 16, which is the current work in 3GPP for the current specifications, and there will be more work in the so-called release 17, which starts in October this year at the level of specifications. This is an updated picture we have in the draft on how do you realize the actual applications over the so-called transport convergence layer, which sits in between the app and the actual dual ICN IP stack. And there have been some updates to the text on how this TCL works and makes the selection of the actual packets to be routed either over ICN or over IP. There are some updates in the draft on this. Most of the updates have been, or they're actually not updates, there were simplifications being made on ICN over 5G LAN. And explaining specifically the new interfaces, which is the so-called NX interface, and it's called NX because the 3GPP didn't come up with a number yet. Usually the interfaces have a number boring like N4 and 6 and 9, whatever. This one is called NX because it hasn't got a number yet. And the forwarding is that's being described there is one of the ongoing piece of work in 3GPP on using so-called path-based forwarding over that new interface to establish an end-to-end LAN connection. So the idea here is that instead of having an IP bearer on your cellular device, you would have a LAN bearer on your cellular device, and the actual LANs can be separated from each other. So therefore, you might have a different LAN for one application versus yet another LAN for another application, or the LAN separation obviously happens between devices, for instance. Right. The section describes how the actual paths are being set up and encoded between the UPFs. UPFs are user plane functions in a 5G system, or for lack of a better word, if you want to associate it with the technology, very often they're SDN switches. They're usually slightly more complex than SDN switches, but as a simplification, that probably gives you an idea what the UPF is. It describes that the path identifiers are bidirectional by design, so you can send back and forth. That's intentional, similar to a LAN communication that you would have. As well as that several path identifiers can be combined into a multicast model. That's the part that's currently being pushed into release 17. So that hasn't been, and there's a note in the text that describes this. Based on the last meeting, while we were actually writing the draft, we expected this solution possibly to be adopted in release 16. It actually has been pushed into the discussions in release 17. So this is all work that's ongoing in parallel to what's going on in 3GPP. So the multicast has not yet been agreed at the 3GPP level. I mean, probably should make the note a bit stronger in the draft that describes that. We also described in the draft then how do you utilize the path-based forwarding to send the packet from one layer 2 cellular device to yet another one. How does that work with a generic packet structure that's described at the bottom through the MAC addresses that are being assigned to the devices at the bearer level. So once you attach to the devices, very similar to today's IP model, you're getting an a MAC address assigned rather than an IP address. And then how is the actual forwarding at layer 2 being realized as described in the draft as well. The next steps we have is to collect feedback from the Icnrg, in particular on the changes. There, as I said, there's a difference in changes. Some of them are editorial. Some the 5G part has largely been updated. It's mainly updating following the specifications. The 5G LAN part is newer because it's ongoing work. But to get comments from the working group would be very useful to see where we are with that. We also, with the authors, felt that in combination to the 4G draft, which is already a research group item, we would like to ask for adoption as a research group item because of the jump to the 5G technology, if you will, compared to the 4G one. And that then would make this document a companion document to the LTE 4G draft that I mentioned before.
Hi, Jan Z. Is this on?
Yeah.
Yes. Jan Zedov, just a process question. So I'm not a 5G expert, but obviously 5G standardization is still ongoing.
Yeah.
So what's your vision? Is then this to be a living document? I mean, that doesn't matter regarding working group adoption, right? Or research group. We can adopt it and still have it as a living document. But do you want to have it hanging on until 5G is done, or do you foresee any major changes in the 5G LAN? Again, I'm not an expert. I'm just.
So for the 5G core architectures, no, this is, I mean, the update there is so minor. It's relative, so there were updates to that part of the text. I said the 5G LAN is a little bit of a moving target at the moment, because as I said, while we were writing it, we were actually expecting the multicast mode. 5G LAN at the moment in release 16 is a LAN-to-LAN communication. It doesn't actually describe how to do multicast, which is slightly strange, right? But it has been moved. It's an agreed topic that's being moved to release 17. So for that part, yes, I would agree us needing to update this as we go along. You know, indeed.
Yeah.
I'm Flame from Nokia. Unfortunately, I haven't read your latest version of the document. Do you have considerations of this low latency work, which is also discussed in 3GPP? Any mappings, for instance, to TSN, that type of
no,
considerations?
We left that for two reasons. I think there's a relation, yes, indeed. One of the reasons we left it out.
For 5G LAN.
Yes, exactly. The question we could add this. The reason we didn't add it is because we didn't want to have two moving targets in a way, because even the TSN is equally fluid at the moment. So we left that out and basically focused on the baseline LAN communication.
Okay. So yeah, this is one of the activities that could help people to understand how actually deploy ICN in a particular network. So it's potentially it's a kind of useful output of this group. So we are kind of positive to this request. Quick question: who has read these two 5G drafts, or any of those? Yeah. Okay. So in this room, is there any objection regarding adopting this draft?
You need to confirm it on the mailing list.
Yeah. Just if you have any concern, now's a good time. Okay, so as I said, so we are in general positive, and we'll follow up on the mail list and see whether there are any other comments.
Okay.
But thanks a lot for tracking the 5G work and doing this. It's really useful.
Yeah, I mean, one of the things we're going to do definitely for the next draft, based also on the feedback, is to put the clear notices to those pieces that are actually being put into the newer releases. So we're going to do that for the living document comment.
Okay.
Okay. Well, while Dirk is getting the next presentation up, the blue sheets, where do we have those? Can you send them around? There's some more people that have come into the room.
If you want have a bigger room next time, please send the blue sheet.
Exactly, yeah.
Okay.
I apologize for the SRO situation, but they allocate room sizes based on how many names are on the blue sheet of the previous meeting.
So we should grab a few people outside. Sorry, I didn't say that. Okay, so this draft is a new draft, but as I mentioned before, this came out of an editorial decision to actually move parts of the previous draft out into a separate one. So in a way, this is the second time the content is being presented, but the draft itself is a new submission. I don't think there's any of my co-authors here. CG is here, sorry. Yes, he indeed is here. So the related draft, as I mentioned, is the previous one. And we took the, in the previous version of the previous draft, the IP over ICN over 5G LAN was a use case for the ICN over 5G LAN, and as I said, we then moved this out. But there is the overlap that we utilize in this draft is to the 5G core design principles. So we're not repeating all of it. We have a certain recap of the 5G LAN, which is much shorter than in the actual 5G draft, because we don't want to repeat everything, if you will.
So that's not hard.
Yeah.
To be shorter.
So what we are focusing on here is how to utilize the ICN over 5G LAN capability and implement actually IP over an ICN over 5G LAN over there, over this type of arrangements. We describe use cases in the draft. I said the slight repetition or recap of the actual realization of 5G LAN in the 5G core network. And then we focus in the main part on the realization of IP-based services. Yeah, hi.
You are not speaking about running IP. You are speaking about running services that normally transit over IP.
Yes, the IP-based services, yes. It made the title very, very long to call it IP-based services over ICN over 5G LAN, but I could have done that. The actual section is called IP-based services, though.
Just either go to the microphone or repeat the question, because we have people on the.
Oh, sorry. Yeah, sorry. The question was whether we run IP over an ICN or we run IP-based services. Yes, the draft is called IP over ICN for short. The section is for a reason called IP-based services over ICN over 5G LAN.
And I'm going to agree with John that it's misleading. This title is misleading. So I think making the name longer is okay.
Okay, good. No, we'll do that. It was literally just to keep the file name and everything shorter. I can make that clear in the actual file name itself. Not a problem. So we have the various items in the third section, and then we do the same as we've done in the change for the ICN over 5G draft, that we link to the deployment considerations in a separate section. So as I said, in the recap, we focus particular on these two new interfaces. The N6 interface, it has a number, so it is a little bit older. The NX interface is that new one that I was talking about before. So we discuss specifically how these interfaces play a role in our realization, but to a large extent, we refer back to the separate ICN over 5G draft in order to keep the section shorter. This relatively, and I have a next bullet item, one which is hopefully a little bit more useful. This rather full picture shows on the left-hand side, if you can recognize that, actual devices talking to each other at the application level on the left-hand side, on the right-hand side. You have a forwarding structure in the middle, which is the 5G LAN network. And at the bottom, we also talk about how to integrate legacy devices that have a full IP, TCP/IP protocol stack over a so-called service proxy. So in short, we describe with it, alongside this picture of how every internet IP-based service is interpreted as a named service transaction that is being routed over an ICN layer, which is the ICN over 5G LAN layer that is described in the separate draft. How the protocol stack flattens to the 4 layers being the actual IP-based services alongside, not on top of each other, and the name-based routing together with the layer 1 and layer 2. So that gives you the 4 layers. We then also describe the interaction of the ICN layer with the name resolver, which you could see in the previous picture. It was somewhere in that wild ASCII drawing in the middle, to register and discover IP-based services, to determine the actual end-to-end packet forwarding information. So in order to retrieve an actual path-based forwarding information, you use the name resolver to do that. And that's been done depending on what type of IP-based service you're considering. The one that we describe in the draft are HTTP services. We also have a mapping for pure IP level services for anything that we can't map, for instance, at the HTTP level. But we haven't included that in the draft. And the question would be, do we want to do that? We can do this. As I said, the interfaces to legacy devices and IP-based peering networks is established to the service proxy devices, which were at the bottom of that picture. And they terminate a traditional internet protocol stack and then communicate with the actual IP protocol stack-based devices. The next step, this is, as I said, is an initial draft. It is longer than the piece that we had included in the joint draft the last time. So it has already more information than we had at the last IETF. But still, obviously, what we're interested in is to collect feedback from the Icnrg, not only about the name of the draft, but also about some of the operations. As I said, one of the questions we had is, do we want to include all of the mappings we have? We have mappings for HTTP, for IP, for CoAP, and for some other services. Do we want to have them as separate sections? At the moment, we only describe how to map HTTP-based services. We also have we haven't updated certain protocol details like the flow management and the mobility handling. They are to be done for future versions. They are included as a section, but just with the editor's note for future versions. And as a next step, we also intend to host a demo at the next IETF in November to show the system, to show a running system for each type of that type of solution. Good.
Nice. Thank you.
Any questions? I know, John, you have tons, but it's.
No, questions wasn't the word.
Okay.
I'll offer a comment, which is that I think, and I'm walking into this totally, I think I would stick with the HTTP-based services. And the reason, roughly speaking, is this. I think that a significant set of people in the larger networking community outside of this room can understand why that would make sense, right? They can say HTTP is kind of an information transport protocol on top of IP. Now I map the services into IC, and that all feels really well, right? I think if you start at this moment in time proposing to map IP directly over IC and all that, you are going to become the subject of one of these famous T-shirts where it's like the recursive 17 layers over layers thing, and I actually don't think you should do that.
Okay, good, thanks. It's kind of like the reasoning that we used to put HTTP at the moment in, because it also aligns better with the use case. I mean, there was a reasoning as well. The use case, if you read the use case section, they are actually HTTP use cases, right? And there's a reason for it, because it becomes more blindingly obvious why you would do that, right? The reason we do IP is, if you don't know anymore what to do, we just hand it to the IP layer. That's the reason we do the IP mapping, right? If somebody comes with a, we had a trial a couple of 2 years ago where somebody allegedly did HTTP, but it turned out it was a ready-made version of HTTP, and we just handed it straight back to the IP layer. We actually detect that and just give it to IP and said, okay. And a lot of the benefits that are described in the use cases are not obviously visible if you do that at the IP layer, right?
Just a comment as well. I'm sure, or I hope you're aware that we had a paper at the ICN conference a while ago. I think Dave was co-author, saying that while you can do HTTP over ICN, a lot of the tricks that modern web pages do are not so easy over ICN, right? Dave, remember the
Oh, I know the paper well.
Well,
yeah.
So I'm just, it's just a comment. I mean, this is standardization, so you're basically defining how it will be done. But maybe you want to have a look at the paper that in reality, a lot of the stuff that we have on the web today is not so easy to do. But that was your conclusion, right, Dave? Correct me if I'm wrong. And then again, it's just I'm
aware of the paper we can put in. Yeah, you know, I'm aware of the paper. Yeah.
So there's a difference between easy to do and you will not like the end result. So it's not so much that it's hard to do, it's that why would you do this?
Well, that's another question.
Right.
So we have some follow-up questions about HTTP. So first of all, there's multiple use cases for HTTP. There's like browser and there's web services. The other question is, what about certificate management and HTTPS? Is there anything that happens special there for certificate resolution? And also for, I was thinking in terms of use case for HTTP, there's both microservices and there's, browser stuff. So microservices may be a different set of constraints. The other thing I was going to ask about was CoAP-S and CoAP, which makes a lot of sense in the IoT use case.
So the section on security, it was not on the list, there was an EG. This section of security consideration is to be filled as well. So that goes to the HTTPS one. We actually have the question about the microservices. We have a draft in the Icnrg, which is on Thursday, where we use this technology at the terminal, so with actual change protocol stacks, to do microservices underneath monolithic applications. So we decompose Android apps, just because we don't only do Android for some reason. We decompose Android's app in real time and establish microservices being delivered over this solution in a terminal. So that does work, and that would be part of the demo, for instance, we could be running in November.
So I bounced up because I heard the word standardization. from the previous speaker, and it isn't, right? This is a research draft, and I think actually it's a really excellent question to say, okay, look, we know that HTTP is warped and abused and twisted beyond all recognition. It's a really interesting question, how well and how broadly the mapping applies. So I think it's a good research question.
Okay, thanks.
Yeah, just as a comment from Jess, I mean, the HTTP mapping here that's not the core part of this work. It's certainly a good topic for this group to consider. So how to do web over ICN in general, and then also address the interesting challenges that Jan, for example, brought up. But it's not the core part of this document. Right?
No, I mean yeah. I mean, for those of you who actually have been in the research group for quite some time, we presented early work of this as early as 2015, 2016. So this comes out of work that we've actually tuned much more towards standardized systems. So we had research prototypes in 2015, I think, that are even demonstrated to the group. The reason we lean now more to what is possible in 5G is because some of the design we utilize is actually being brought into 5G standardization. Not everything. The HTTP mapping isn't, right? The HTTP mapping is really something that's much more related to the ICN discussions, which is why we have the discussions here. But stuff around 5G LAN, path-based forwarding, etc., is currently being put into 5G standardization. It might be really part of running systems, at some point in time. Good.
Okay.
Thank you.
Looking forward to the demo in November.
Yeah.
That's great. Okay, Hitoshi, you're next. Click on, yeah.
Okay, so this is a CCNA for draft update. So this is a version, currently it's version 2. Oh.
What's going on here?
Okay. So this is a changes from version 1 to version 2. Thanks to Dave's comment in a mailing list, we clarified several terminologies. The first one is routers or content hoarders. They are sometimes misleading, so I clarified the meaning of routers and the meaning of content hoarders. Usually, actually, routers is just a mission, the node who has a mission to hoard the data and the interest packet, and the content hoarder means that it's a cache router who cache the corresponding cache that is requested via interest packet. And the cache versus unexpired cache. So this is something like a mixed in a document. So I clarified the cache is just a cache that may be expired or may not be expired. And expired cache is, as it says, it's not expired yet. And the section 3211, I changed the reply sub-block. This is also thanks for Dave's comment. I scale up the object size for reply sub-block. Previously, the content object size was a byte. That byte is a unit, and now the unit is a kilobyte. So totally 4.29 terabyte can be supported as a maximum in a 30-bit, 2-bit field. And the counter, for the refreshing the counter, so this is also, there was no discussion about the status of the refreshed contents. So we add this statement: if the cache is refreshed after reboot, the counter must be refreshed, must set to, so the counter must set to 0. And if the cache remains after reboot, the counter must not be refreshed, which means must be kept as is. And we also need to add some IANA section, but even though it's not completed yet, but we added the IANA section. So this is just a recap of CCNA for behavior. So CCNA for user initiates request message with request block and sends a message to last hop router, and the last hop router and other router along the path insert their repo prop in the hop by hop header and forward the message here. Message based on their fields in a hop by hop manner. And the caching routers who has a specified content or first hop router append the reply block and the reply sub blocks to the message and send the message as reply message towards CCN info user along the bit entry. This is a basic behavior. So the default behavior, especially for the situation, the router supporting the router supports the multipath FIB. Some router may have strategy for multipath forwarding. When it sends the interest message to multiple neighbor routers, it may delay or prioritize to send a message to the upstream routers. The CCN info request as a default complies with such strategy, which means that the CCN info user could trace the actual forwarding path based on the forwarding strategy. So this is something like a data plane trace. But we also add some complex situation we call the full discovery request. There may be the case that CCN info user wants to discover all potential forwarding paths based on router's FIB. This means that it's not a request, any broadcast request. So the FIB may have a multiple entries for specific content, but according to the strategy, as I said, it's maybe delayed or prioritized. But if the CCN info user request full discovery request, then if the FIB has 2 entries for specified content, then the request packet goes to the 2 or multiple requests, toward multiple forwarders. If a CCN info user sets the F flag in the request block of the request message to the request to request the full discovery, the upstream routers forward the request to the all multiple upstream routers based on the FIB simultaneously. Then the CCN info user could trace all potential forwarding paths. Note that some router may ignore the full discovery request according to their policy. In that case, router terminates the request. This is a full discovery situation. When a CCN info user requests a full discovery to receive the different reply message forwarded from different routers, bit entry initiated by CCN info remain until the configured CCN info reply timeout passes. So currently the reply timeout is set, maybe I remember 3 seconds as a two or three. Please read the draft. 2 or 3 seconds as a default. In other words, unlike the ordinary interest data communication in CCN, if the router accepts the full discovery request, the router should not limit the bit entry created by CCN info request until the timeout period expires. So the conclusion for at this moment, CCN info, which is compatible with CCNX version 1 TLB format, but of course it's compatible, but we add several new packet type and type values. And it is a powerful network tool providing various information in CCN. And the most important point of this draft is that we need to have get some agreement on, especially on multipath and security. So these are the maybe biggest issue. So please read the draft and give us a comment. It's really welcome. And the implementation is almost done in our open source implementation CEFOR. CEFOR is not only for CCN info, it's really compatible with Metis forwarder. So we already tried the interoperability test with Metis, and it's a full set of CCN forwarding demo and the content store. So it's already included in the CEFOR. So if you are interested in, please access to the CEFOR.net website. Okay, that's all.
Thanks, Hitoshi. Any questions or comments?
This is pretty important work, and it really needs a lot more eyes on it from people in the group. I know, I haven't looked at it since the last iteration, right? So I gave most of my comments, but I need to go through it again. And I think we really ought to look at one area that I think we ought to think a lot about is the whole question of flow balance and how we continue to achieve flow balance with a scheme like this. And the second area is whether doing things like this increases the priority of adopting work around multipath and path steering, which has been done in papers in the academic community, but we don't have an Icnrg draft on path steering, because path steering in this sort of like as a marriage that could be really nice.
So one of the other issues regarding security is in the IP world, you kind of do the, there are different caches and DNS usually decides which one you use, and then the trace route you do on the IP layer just goes to one source, right? And here in the ICN world, we have both intertwined, as we know. So one question from a security perspective is if, or I guess that you are asking for security comments, right? So one issue could be, would need to have to look at it closer, is that can you use this for discovery of caches that, you know, maybe the ICN service provider doesn't want you to discover because you usually routes to the other one, or, I mean, then he would probably block CCN info. Is he supposed to do that? Is he allowed to do that? I don't know.
Right.
Right?
Right. You can always lie.
Well, but certain ISPs have gotten into big trouble for lying, right? Regarding, for instance, Comcast with peer-to-peer traffic and stuff. So
Yeah, you can always lie. And if the user believes your keys,
well, yeah.
then they
You can
deserve,
always
they get
lie,
what they
but-
deserve. And if they don't believe your keys, then
You
they
can
won't
always
believe the
lie, but
lies.
If the FCC finds out, you might get into trouble. I'm just saying, just a comment. I mean, these are things I think we need to discuss.
Thank you, thank you.
So actually, let me up-level this just a second. One of the things we discovered in NDN with discovery was that it was trivially easy for an attacker to do cache exploration, right? So ultimately, the NDN people got rid of the features that
That's
would
exactly
have
what I'm
allowed
talking
somebody to
about.
do
Yeah.
cache exploration. We don't want to reintroduce that problem by introducing CC
That was
info.
exactly
So
right.
whatever security is in CC info should not enable attacking consumers to do cache exploration. Right.
That's exactly
Is that
what I
what-
wanted
is
to
that-
say.
that's-
That was exactly my point, and I just want to reiterate that in this respect, ICN is really different, and this is different than traceroute, because in the old world, it was two different things, and here it's intertwined. But yeah, this was exactly my comment, yes.
Right, right. There might be a simple solution here because you have enough, I think we have enough information so that a cache would never return something that the producer wouldn't. In other words, if you send an CC info and something's in the cache, it's relatively easy to ascertain whether the producer would have answered that question.
It might actually also be the case that in this case, you would allow, like we were joking, but you might actually allow service providers not to answer CCN info requests if they don't want to disclose all their caching secrets, you know. They're
Right, I think this is a longer off discussion, but I think I want to be really careful about taking the position that you don't answer the query. You may answer the query with not all the information that would
Well, I'm
expose this, but what we've learned with traceroute is that the refusal to answer a traceroute query and just drop it on the floor is really negative for debuggability of the network. And we're trying to, you know, I don't think we want to replace, sort of like go around the wheel again with what happened with traceroute and ISPs where they just dropped trace routes and refused to answer them rather than figuring out how to allow trace routes to propagate and see the parts of the path that aren't sensitive, right? So,
Yeah,
so
just to finish, but just to be clear, we're just talking about the extension you call full path discovery, right? We're not talking about the core mechanism, I think, because the core mechanism just answers with one cache. Yeah.
So this is a really good area for people to be looking at and suggesting what the right security versus manageability trade-offs are.
But the full discovery is not broadcast. So even though you get some answer from full discovery, that both or multiple replies must be legal because the FIB already coordinated. Just according to the strategy, some of the upper path is prioritized, and the secondary or thirdary, they are just prioritized, so lower priority. So anyway, so the full discovery is not, again, it's not broadcast. It's not a full, well, the broadcast discovery. So it's a coordinated discovery, but the strategy may not, let's say, something like ignored. Such kind of a prioritization may be ignored. So this is a difference. But anyway, thanks for your great comment. It's really interesting. But also several discussion about the security threat or something like access control and so on. We already slightly mentioned in the draft. So please read the draft, and we are really happy to get your comment again. Thank you.
Yeah, especially since we got the base specs for CCNX out of the door. Now it's a really good time to ramp up activities on tooling as this. One question on C4. So you mentioned it interoperates with Metis.
It's interoperated with Metis.
Yes.
We tried to some test for the interoperability with Metis.
Okay. So probably, I mean, if you can confirm that maybe also later, whether it's actually compatible or actually complies to the CNX RFCs, that would be good to know.
Mm-hmm.
And we could mention that on our wiki page.
Mm-hmm. Mm-hmm. Yeah, I already mentioned it in a wiki page.
Fantastic. Okay. Thanks, Hideshi.
Okay. Okay.
Okay.
Thank you.
Thanks a lot. So we are switching gears to IoT and low power networks, and Thomas is going to give us an update.
Yeah, something completely different. This is actually a story that's going on for a while, and Dirk just said it wouldn't be bad to give a brief recap on what this actually is about. I don't have slides for this, so I'm doing this hand-wavingly. If you look at low power lossy networks in the IoT of constrained devices that operate on batteries, then you have different link layers, like for instance 802.15.4, Bluetooth Low Energy, or you have these LWPAN things like LoRa and stuff. So these wireless technologies have the property that they that they are very constrained in several ways. They can only send a very low rate of packets. The maximum transfer unit size is pretty low. So 802.11 has 127 bytes, including the layer 2 headers. So this is all different from the common picture we have from fixed networks, big pipes that are interconnected and where you can actually do a lot of complex operations without doing any harm. And to adapt the IP world to this, there's a lot of work has been done and is still ongoing in several groups. The most prominent was the 6LoWPAN adaptation layer that adapted the IPv6 world to 802.15.4. And if you want, so this is the correspondent work for ICN, which is in some cases pretty similar, or even just transfers the concept one-to-one, so it doesn't reinvent them. And there are a couple of things in this draft that are very specific to NDN, CCN, NDN. It addresses both. So what is rather generic? Well, generic is that if you are in a 15.4 network, you need to tell the layer 2, because it doesn't have a type field or a payload type field. You need to tell the receiving node that reads the layer 2 what is the protocol. So this is done via a dispatch field in 6LoWPAN. So we extend this dispatch field to address that there's NDN or CCN coming and not IPv6. Then there's a more or less standard fragmentation mechanism that fragments larger chunks onto these small MTU sizes. That is more or less straightforward to transfer to NDN as well. And then there are a lot of mechanisms that relate to compression to make the transfer of packets or of data chunks more efficient. And these compression mechanisms address headers. Not data. We are not looking at entropy encoding of data or so. That's not the case here. But we're looking at headers and trying to reduce the header sizes in the most versatile way. Versatile means getting the thing small, but do it in a way that it is not addressing every narrow corner case, making the thing extremely complex, but being very useful for, let's say, 80–90% of the cases. And that's where we are actually in, and this is what this draft does. And it is in the middle of more or less converging discussion. So we had 2 updates since the last time. One update last time was last presentation here was Prague. One update was from version 2 to version 3, and the other one is from version 3 to version 4. So what did we do in this first step of update? The key discussion that was around was first on the way how to encode timers. That's the time TLV section, and the second was how can we sort of even simplify the scheme to by just not taking or accounting for exceptions that are more or less not so important. So what do we do? First, we extended editorial stuff. That's editorial stuff, also quite a number of just writing and clarifying. And then we selected the time TLV values. That was a longer discussion, and we also simplified the way how the compression works. And here's some details. So the idea with the time TLV is borrowed from an LoPan RFC. That's basically the idea to have to compress the time values into 1 byte, and the byte should be able to cover decent ranges of numbers, so ranges from sub-milliseconds up to days, but at the price of granularity. So you can't express every number, but you express can express many numbers in the small range and fewer numbers in the large range. This is done by an encoding using exponent and mantissa, and then using an exponential representation that is written on the slides here, and you get things that are in these ranges of sub-milliseconds to 45 days. The point here, or the thing that was actually on the discussion here is that if you compress an arbitrary number in this way, then you can't recover the number exactly. You can, if the number is not representable in this way, then you're actually you need to round to the nearest or nearest larger number, which is actually in the draft now. We had a discussion whether we wanted to, with Dave also, whether we wanted to actually change the whole timer system in CCN, but this actually didn't, that was a bit too late, I guess. Huh?
Oh, it's definitely too late for the current specs, but
yeah.
Since we're going to start opening up this, I think this is high on the list of things we might want to do. Right. So for any time values in CCNX that aren't inside the security envelope, we'd be able to compress them this way. And for most of the uses of timers in CCN, it has the nice property that this exploits, which is that the longer the time, the less precision you need in the actual time things are being measured. So this is something we'll discuss as perhaps being done globally for all the specs.
Jan Sedov, I just wanted to mention that this problem is, well known and old. It's the same as floating point numbers, IEEE, floating point encoding. Yeah, so basically what you're saying is either you have a longer format and you can be more precise. If you have just very small, you have to round, and that's...
Of course, the problem is that you have to recalculate checksums if you can't recover if it's inside the security envelope and you can't recover the original number, then you have to recalculate checksums, which is just not so...
Right, so it would be better if the uncompressed representation was actually minimal, so it doesn't have to be separately compressed.
I'm not aware of use cases where actually this range of numbers is clearly insufficient, because I'm not sure whether you really need 43 dot blah 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 days time to live value or so something like this.
Yeah, I mean, the one that would be the delta for expiration over current time, right? Because data expiration might very easily be longer than 45 days. Right, but all the rest,
Yeah.
we'll look at it. We'll look at it.
Okay, that's the one. So, and the second is the state compression scheme is built in a way that we are trying to cut out a lot of type and length values from the TLV encoding, and this is by fixing an order and fixing certain types, and the scheme gets more complicated if you give more freedom to what you encode. And there was one discussion on hop limits in NDN. NDN has an optional hop limit; it is not mandatory. And if you want to encoding optional hop limits, then it actually blows the thing a little bit up. So we actually decided to say, okay, we always we assume there is a hop limit, and if there is no hop limit, then we can just insert a 255, which is a maximum hop limit size that doesn't do harm, and then we don't need to deal with the case that there is no hop limit. And the same as we also we assume a nonce is present, and then we can actually fix the order, and then we can deduce that if an interest lifetime is there, then we can actually deduce it from the header length, because it's the remaining bytes. And the time TLV encoding is I already mentioned, and the same is a little bit for the data. So if we fix the order, we can actually once again deduce the last field, and that's the freshness period. This is optional. If it's there, we see it from the header length, and if it's not there, then the header is exhausted. And in the cases, I mean, that's always the fallback in the cases where all these schemes don't apply. So, for instance, the freshness period cannot be converted to the TLV or whatever. Then we can always fall back to sending uncompressed data. So it is there's always a fallback that is not efficient but compatible to everything. That's the escape here. Of course, the objective is to hit most of the cases, to be applicable in most of the cases. So the second update we had is very recent. That is, we had a Zhongjiao, I can't really pronounce the name. Chenshao had kindly provided a thorough review for the version 3. And well, we had discussions on the list. We also had offline discussions on some details with him. There was a number of things just to straighten out, and this is enumerated here. And there's one discussion point left, which I bring to the group on the next slide. So he addressed a couple of things. So this was actually a mistake to have it digest at the data compression, at the data part. He pointed out, which was a very smart pointing out that the forwarding hints could also work with a TLV compression scheme that actually applies for the names. So we added this. Then we had some adaptation on the newest versions of NDN. There was a parameter renamed application parameter. Well, we adopted this. That's minor details. Here was also an editorial thing. Then there was, there was the point that actually NDN is a moving target, as you call it, is changing, and we sort of clarified that we are addressing certain specifications, and if actually things move away in the NDN spec, then this document cannot handle it, and then it needs to be either uncompressed or a future version needs to do it. The discussion point here is actually, I wanted to bring this to this group, is the question about compressing names. So we always assume that we have all name components of the type generic name. That means it's opaque. NDN foresees the option to have type names. So for instance, you could have part of the name being a temperature with some semantic and some syntax, or being something, I don't know, some counter or some of a certain length. This has not been addressed in the draft, and actually we are not really excited about addressing this because it makes it complicated. But the question was raised, should this be incorporated? Should this be addressed in this work, or shouldn't it? I mean, it's a trade-off. I mean,
And just to understand, if there would be such thing as a gateway from NDN to this format, you would just go, you would lose that information, right? But that would still be possible.
well, no, I mean, currently it would be if you have type name components that we couldn't compress them, so we would send uncompressed. So the whole compression scheme would only address this generic name components.
The figure that suggests that you can kind of transform from left to right.
Well, this is what we do currently. So we have
Right. So you lose that information.
No, you can't lose the information, because when the data packet comes back, you won't be able to check the signature.
no, we are not losing the information. We are fixing the type here. So that's why we cut it out. Yeah, the type is generic name component, and that's so we don't transmit it. But if we want to handle different kind of types in the name components, then we can't just elide the type, because otherwise we can't recover it.
So we have an IANA registry of types for CCN.
Yeah.
Right. A few of them we expect to be widely used. For example, chunk number.
Mm-hmm.
So it may be worth going through the IANA registry, and for things we expect to see a lot,
Mm-hmm.
Have a fixed compression for those.
Mm-hmm.
I mean, I see the problem where if you want to be able to compress something where any, the type is, you don't know anything about the types, right? You're going to lose a lot of compression in an attempt to carry the type information opaquely, right?
Yeah.
So there may be a compromise here where there are, how many types are in the registry now? Like 2, 3? Maybe four.
Yeah.
And of those, maybe only we can talk about which ones we actually expect to see commonly used. And we can, you can do, constant dictionary, static dictionary compression of the types that we expect to see. I had one quick question. When you say we don't compress, do you lose all the compression of everything, or only the compression of the name?
I don't want to answer this generally. I mean, there are parts in the draft where you can leave out the...
Yeah, because there's coupling there. Okay.
It's a bit complicated. I mean, I don't want to say something wrong here.
So, okay. My opinion, for what it's worth, is that we should deal with the types we expect to be widely used and not worry about the general case.
Okay. Yeah, so we can take a look, and we can maybe also exchange
Other
some...
people should weigh in on this, however.
Yeah, of course. I mean, feedback solicited, and we can maybe also exchange some experience with Mark on that.
Yeah, hi, Mark Moscow. When I had done the compression for CCNX before, which was unrelated to your draft, I used a dictionary approach where you set up state between, the receive, each hop along the path would have state from the previous hop.
Oh, that's a stateful.
Right.
Yeah.
So it's a stateful
Yeah.
compression. But there are, the other thing that you can exploit is lengths for name components usually are kind of short. So I was able to combine the type into the length bits, right?
Okay, okay.
So I would say, oh, I just have like 4 bits for type and, 4 bits for length or something, not exactly that, but, I was able to put some amount of type information in there. Or if you have repeating fields, you could set up just a little self-contained dictionary as part of the compression. So
I mean, there are actually two ways to do this. I mean, this draft also addresses stateful compression, but not for the names now. So we could include this into stateful compression. Types. I mean, leave this approach for the generic, and then if there are type name components, then put this into stateful compression. The other would be like to squeeze this a bit, having some. I mean, here's only the length of the overall name, and then you have like no type, no component length, and a stop bit. So that's actually that's very very much compressed. So there could be something in between.
Yeah. I'll look over the draft again and see if I can make some suggestions on that. But for names, usually you have enough repetition between all the different names in the packet that just doing a teeny dictionary at the start, would let you do arbitrary compression, but still get a lot of compression.
Yeah.
So.
Kind of related to this was a discussion that came up yesterday in the 6LoWPAN group. We were talking about the long addresses for IPv6 and using prefixes and having essentially gateways that add prefixes or drop prefixes. Not exactly NATs, they are like network boundaries.
Yeah, I know.
And so you could apply the same concept for names, is you have something that adds or reduces, eliminates prefixes on names.
This is a stateful compression of 6LoWPAN, yeah, and we also
only at the gateway, not the.
Yeah. This actually exists here too. So we already have the stateful compression of common prefixes here, which is that's more or less straightforward translation. So you just cut the prefix that is common to the communication, and then you fix it at a nodal state. Yeah. But here it would be something like what Mark means is it would be something like we have a name that is built of component type 1, type 2, type 3, and this name repeats. So we can say this be of name type 5 or so, and this has this structure. So we know that we are actually communicating a type 5 name, and then we can write down the compressed format. So what Mark says basically is that the names are not arbitrary, but they follow some logic. So I mean the structure of the name, of course. Yeah. Okay. Yeah. Okay. So we straighten this out. Otherwise, we believe that this is more or less matured,
Yeah. Thanks. I think this has evolved quite nicely, and it's also really important work, to be honest. Who is interested in IoT and ICN? No, that's more of you. So who has read the latest version of this draft? Oh, not the latest, but the one before. Yeah. So a version. Okay. Okay, so there are two things. So one is we want to evade the outcome of the name component discussion.
Yeah, please.
And but second is it would be good to get a few more eyes on this draft. So maybe somebody who maybe hasn't read it yet could have a look with fresh eyes, so that we could just do some quality assurance in the group here. Can we get a volunteer for reviewing this?
What's your time frame for that? 2 weeks.
I think we're not.
Next 2 weeks, no. But
Do me a favor and say 47 seconds. Would you please just
That doesn't have an optimal logarithmic encoding.
Yeah.
fair point.
So it's not super urgent
I
because,
will do it after I get papers finished that are due in the next week.
but that's probably still okay, right? Because we
That's-
want to have the discussion anyway. Okay, great, thank you. So just one additional comment. So Thomas didn't mention it because he's super modest and nice guy, but so this is really interesting work in a sense because it really demonstrates the usefulness of ICN. So there's other work by that team that demonstrates all the nice properties in terms of robustness, performance, and so on. So comparing ICN over low-pan networks with like IP-based stacks. And the results, if I may say so, are really, really promising. So this is really one area where ICN really shines. And so that's also why we want to get this out and publish this as one of our next specifications. Okay, thank you. And we're moving on with name evolution and having Jongha on the stage. And the clicker is where?
Here.
Who hasn't signed the blue sheet yet?
Your blue sheets?
Here. Ah, very good. Thank you.
Okay. Hello, everyone. I'm Jongha Hong from Icnrg. This is the update on NRS document. We have a two NRS document which is adopted after IETF 102, and one is requirements for NRS in ICN, and the other is architectural consideration of ICN using NRS. The first one, the title of the first one has changed it into design guidelines. The reason why we changed it, when we say requirement, it is too strong. And also the things that we have described in the draft, well, you cannot qualify or require, you cannot meet all the requirements in one system. So it was too strong. So we changed it into the design guidelines, so which means that these are things that you can consider when you design the NRS for your system. So the first one, design guidelines for NRS in ICN. This is the 02 version. We haven't changed the name file name yet, so it has the requirements in it, but next time we'll change it into the guidelines. And we have 6 authors. And this document focuses on NRS itself as a service or as a system in ICN. And this document also defines what is NRS in ICN. We also categorize the NRS approaches and also provides the comparison of each among the approaches. We provide the functionality of the NRS in ICN, which includes how NRS is used in different ICN architectures. We provide the design guidelines as well for NRS, as well as the security considerations. On the left side is the previous version. On the right side is the current version. On the section 3, originally we had the analysis of the NRS approaches before, but in the previous version we removed it because we concentrated on the NRS system itself. But somehow we had a discussion among the authors that we better to have these approaches back, so we put it back in there. So let me explain a little bit about what these approaches are. The first explicit name resolution approach is you have the name resolution service system as a standalone in your architecture, and that's most the user way. And the second name-based routing approach is like a CCN and NDN. You do the hop by hop name resolution when you forward the interest packets. And the third is a hybrid of those two. And then we give some comparison of those approaches in subsection 3.4. And section 4, it was the originally way back. It started from motivation of NRS, and then we changed it to the objectives, and now we change it to the functionality. So these are things is how NRS can be utilized in ICN. So, and also we had the use cases before, but we integrate this use case into the each functionalities. So, and also for this revision, we added another functionality, which is the supporting metadata. I'll explain in the next slides about it. And regarding to change the title, obviously the section 5 title is design guidelines, which is the main contribution of this document. And before, when we had the requirements, we categorized it in terms of the service aspect and system and security aspect before, but we integrate the service and system aspect into the guidelines, and we separate the security aspect to the individual section to the security considerations. So this is the major updates for this current version. I already explained that the title has been changed and subsection object has been changed to functionalities, and also use case integrated into the functionalities. And the support metadata is you give the name to the NRS system, and the NRS system returns a set of the metadata. And this metadata could include the alternative object locations or supported object transfer protocols or caching policies or security parameters, the data format or hash of the object data, etc. And this metadata could be used for selection of the object transfer protocol or security mechanism or egress in interfaces and so on. And again, the title section 5 has been changed to the design guidelines. And the second draft is on architectural consideration of the ICN using NRS. And we added 2 new authors, so we are 5 now. And the scope of this document is this focuses on things related to the ICN architecture. So the difference between the first one and second is the first one was we tried to focus on the NRS system itself, but the second is these are things which is related to the ICN architecture. So things you have to consider in respect of the ICN architecture here. So this document also discusses how ICN routing system has to be changed when NRS is integrated into ICN, because NRS system is not a mandatory to the ICN. So you have a certain purpose to use the NRS in your architecture. So when you integrate your architecture, then there are the ICN routing has to be changed. So we discussed it in terms of the procedure and latency and security respect. And then we provide the ICN architecture considerations for NRS, which includes the procedures of NRS system with name mapping records and ICN protocol design for NRS system, and how to process the result of the name resolution. And this is the major changes from previous one. We added some terminologies And section 5.1, we change it from the name resolution to the name mapping, record registration, resolution, and update. And this is about the here. The terminology actually originally in here, the new terminology is the name NRS server and NRS reservoir as the NRS components, and the other two is name registration and name resolution as the NRS process. These four terminologies was defined originally in the previous version of the requirement document, but before, like we had, but these four is covered only by the explicit name resolution service approaches. So we remove from this terminology from the first draft, since the first draft covers the both approaches, but this draft assumes explicitly the explicit name resolution service approaches. So we thought this terminology is appropriate for this document, so we moved from there to this document, and then we changed it, the subsection 5.1. It was a short description about the who does the name resolution, or how does the name resolution, or when does the name resolution in the system. And then we keep the contents of that for this subsection, but the way we describe has been changed into the, we explain what is name registration and name resolution, and what is the name record updates. According to that, we still explaining that who does the name resolution and when does the name resolution. So in this picture, we haven't added this picture in the draft, but just to just put it in the slide that the name registration can be done by producer or ICN router. Also, name resolution can be done by consumer side or the ICN router. That's your choice when you design the system. Yeah, this is all I have for today. And I think it's mature for our last call. So any comments, please?
So while Mark walks up, just for clarification, so these are two informational documents, and so the idea here is that we're not saying every ICN system needs name resolution. It's more like, so if you are inclined to use name resolution, these are the considerations regarding the, say, NRS system and the impact it would have on your ICN system.
Okay, yeah. Hi, Mark Moscow. So my understanding in the design considerations is the name resolution can be done on a prefix basis. So I could register a prefix and have all names under that prefix, use that resolution.
We didn't assume any type of the specific type of the name. What the way we describe here is any type of the name, you just register along with some information.
Mm-hmm.
So depending on how you use it, the information can be different things.
Okay.
So yeah, like for support mobility, you could get a location, or for like routing scalability, you can use NRS. Then you can get the another name.
Okay. Yeah. At the interim meeting, we were talking about discovery, meaning I give you a name prefix and some parameters about the content I want to search for under that. And there was a question, Well, that sounds like a name resolution service.
Yeah, sure, yeah.
So do you envision something like that could be put into an NRS?
Yeah. I think in the like a functionality section, yeah, we could include it.
Okay.
Yeah.
Yeah, I was just wondering, you know, if you wanted to keep it simpler, or you wanted, or if you thought, oh, maybe this sort of like search on names could be done, because it's really a name to a name resolution, not a name to a locator resolution.
Mm-hmm.
Yeah.
Name to like information, but that information could include all the types of like names or locator or whatever, including any metadata.
Okay.
Yeah.
All right. Thank you.
Yeah. Thanks.
So I'm going to expose my lack of knowledge here. How does this relate to the two different kinds of name services that Mobility First provides? One is the name certification service, which also does kind of human-friendly name to GUID, and the other is the global resolution service, which goes from GUID to something that helps you find things. But so they've partitioned the name resolution problem into two parts intentionally because they have different kinds of requirements.
Mm-hmm.
So I'm wondering whether you've thought about that and how this relates to what they're talking about.
Yeah, we try to include all types of the name resolution, and we deal with the we didn't provide the we tried not to fry the too deep in each cases, but for like what you're saying, I think we could include it as a mobility support functionalities like that. Yes, so we covered it. Yeah. But we didn't, in the draft, we tried to avoid a specific like mechanism or system or something like that. We tried to like more give the general information about it. So.
Yeah, Dr. Larson, I wanted to make sure that it would be good to actually highlight these two different steps, because another system where it might be a bit unusual, but it actually includes the notion of name-based routing, is 3GPP 5G. 3GPP 5G has the option to do control plane routing based on name-based routing, strangely enough. But it actually has two steps. It has the so-called service discovery profile resolution and the actual name-based routing solution. It's unfortunately all called name resolution function, which is the thing that I disagree with. But it makes sure that it differentiates these two different steps. So it says, yes, I want to do, I don't know, an authentication management function, and it's Dave being in the US under that subscriber ID. Please give me an actual real name I can route on. And that's the very first step. The second step is the one, once I have that name, how do I get to the instance that actually can serve it? And it seems it might be quite useful, because it's very similar to what Mobility First did, to actually make these two different steps quite clear in the actual draft, that there are two different problems. For instance, in our system, we don't implement the first one, because the first one is a lot about business logic. How do you translate a subscriber onto a name? From a routing perspective, you might not care that much about it.
Yeah, I can comment on those two things. Is that the way these drafts are written is that we're describing these at the high generic level. So you have the explicit name resolution that you map something at the server like DNS or something like that, and you have the name-based routing. And then we have the third thing, which is a hybrid approach where you combine these in some ways. So I think all of these alternatives are covered at the high general level in the draft. And I believe we have examples from Mobility First in the draft as well. So
I was going to say, you should mention some of these other cases in the draft.
They are.
But I think one of the things that's interesting about the Mobility First model is that they name the high-level resolution service. They recognize that there may be many of them. I could choose one that's fast. I could choose one that's specialized. I could choose one that has certain characteristics. So there are multiple different possibilities for that name resolution service. But the understanding is once you've mapped to that name, which needs to be globally resolvable, there you need one. So there are different requirements and different kind of constraints on those systems. which is part of the reason you want to separate them, because in some cases you allow for many different possibilities, and the other you must have exactly one. So thinking about that,
I am fully aware of what you're saying, and we've been very careful to talk about the name resolution service and not the name resolution system or multiples. So what we talk about is that you can have a service that do name resolution, and that can be implemented as different systems, and you can have things that scale between different application scenarios.
I should go read it. It's really the answer.
Yes.
Okay. Okay, great. So, I mean, this work has been discussed and reviewed a couple of times here in the group. So what, and we think it has reached a good level of maturity. So what we'd like to do is issue that research group last call on the list now. And of course, if there are more comments like this, we will deal with them. But we think that that's a good next step now for us to just have people read it again and come up with their substantial comments. So that's going to happen after this meeting.
Okay.
Thank you very much.
Thank you.
All right. So that was the end of our technical agenda. Just a few pieces of information. So I mentioned the ICN conference. There's actually another ICN event even before that, and that is the NDN community meeting September 5th and 6th in Gaithersburg, Maryland. At the Hong Kong ACM conference, so that's going to be the main conference. The day before, there's the Touch NDN event. And we would also like to have an interim meeting after the conference, so on Friday the 27th. So that means if you come to Hong Kong, you have a really nice week of ICN activities going on. You can thank us later. No big. So we have always been doing this for the last years at the conference, because it was actually always a really nice opportunity to, for example, do a deep dive on certain interesting topics that came up at the conference, give people a chance to really discuss things with more depth. So that is, we felt that was actually quite useful in past years. Other than that, we are also planning for an Icnrg meeting at Singapore, where you have to see the demo by Dirk. So it's going to at least be one regular meeting like this. Further details we can discuss in Hong Kong, for example. With that, we are done. Thanks a lot for coming. Please attend IETF Open if you're interested. Thank you.
Can you tell us what IETF Open is?
I think it's after the lunch break.
No.
Oh, sorry. It's a second
session after lunch.
Second afternoon slot. What's the other blue sheet?
Blue sheet. There's another one of these. The other one.
We need to issue RGMS calls for NRS. And we'll wait for the next OPEN. Right. And we need to bug Colin about the IRSG reviews. Yes.